guests, faculty members, and students on behalf of the entire Team Silicon. At the outset, for me, it's indeed a matter of great honor and privilege to be part of such an elite conference. As we march ahead in the 21st century, we get to witness a plethora of technological advancements that are in a constant state of flux. Research, innovations, technologies, and trends are not confined to the boundaries of a particular domain. Rather, it has become a beautiful amalgam of various disciplines. At this point, it's imperative for technical institutions to keep abreast of such advancements. Silicon, in its pursuit of building technology for human progress, wishes to be in tandem with the technological advancements and serve as a metaphorical melting pot for such knowledge. CCPIS 2023 is a small step towards the same. Today, we have amongst us extremely accomplished dignitaries who are stalwarts in their domain. It's a matter of privilege for Silicon that we get an opportunity to be a part of their knowledge sharing sessions. So without much ado, I'd like to go ahead with the inauguration. So at first, may I please request our chief guest, Dr. Banshidhar Majhi, our guest of honor, Dr. Chinmoy, our conference general chair, Dr. R. Nagaraj, our principal, Dr. Jaideep Talukdar, our Dean Research, Dr. Jayashree Das, and organizing chair, Dr. Biranchi Narayan Rath, to please come up to the dais. So please. Now I'll request our volunteers to present the bouquets to all our dignitaries as a token of our respect and appreciation for their time. We can have a huge round of applause for them. I'd like to again extend a very warm welcome to all our dignitaries on dais on behalf of entire Team Silicon. Before we start the event, I'd request all our dignitaries to please light the holy lamp before the beginning of the conference. So please.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणवन्दिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि गानचतुराय गानप्राणाय गानोत्तरात्मने गानोत्सुखाय गानमत्ताय गानोत्सुकमनसे गुरुदेवताय गुरुकुलस्थाय गुरुविग्रहाय गुह्यप्रवराय गुरवे गुणगुरवे गुरुदैत्यकलक्षेत्रे गुरुधर्म सदाराध्याय गुरुपुत्र परित्रात्रे गुरुपाखण्ड खण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढकल्पाय गन्धमत्वाय गोजयप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि।
ये बड़ा छोटा आ रहा है बड़ा सर क्योंकि वो स्क्रीन शेयर हुआ है बोल के वो वही आएगा स्क्रीन शेयर जब तक ऑफ नहीं तो नहीं आएगा स्क्रीन शेयर कहाँ पे स्क्रीन शेयर वहाँ पे सर मिनिमाइज कर दीजिए तो सेटा কিন্তু आपण पीपीटी ही शेयर करते आपण যদি एंटर स्क्रीन कर तो अच्छी दीजिए ठीक है कैमरा वन है
to deliver a beautiful rendition of our own anthem, Bandi Utkal Janani, to mark the auspicious beginning to this vibrant conference. It's a song which is dedicated as an ode to our motherland. So I'd like to request all our dignitaries, all our audience to please stand up as a mark of respect. Please, Sujeshnath Kalinga and Pratiksha.
Hello. Vande, Vande, Vande. Vande Utkala Janani, Vande Utkala Janani, Vande Utkala Janani, Vande Utkala Janani, Vande Utkala Janani. Charuhasamai, Janani, 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 Vande Utkala Janani, Vande Utkala Janani. Payodhi vidhaut sharira, Shubhrati Nikula Sitala Samira, Janani, 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 Vande Utkala Janani, Vande Utkala Janani. Ghana Ghana Vana Bhumi Rajita Ange, Neela Bhudara Dhara Sajita Range, Kola Kola Mukharita Charu Bihange, Janani, 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 Vande Utkala Janani, Vande Utkala Janani.
Thank you. Thank you once again, Sujishna, Pratiksha, and Talukdar. Those were very beautiful renditions to both the songs. I'd like to request the audience to again give a huge round of applause for the same. Now, with the inauguration, may I please request our principal, Dr. Jaideep Talukdar, to give the welcome address, please. Sir, please.
Good morning, everyone. Welcome to this inaugural event of CCPIS 2023. On behalf of Silicon Institute of Technology, Bhubaneswar, I take immense pleasure in welcoming you to CCPIS 2023, a three-day international conference on circuits, power, and intelligent systems in the temple city of Bhubaneswar. This is our first independent international conference organized by Silicon, so it's a very auspicious event. I welcome our chief guest, Professor Banshidhar Majhi, Vice Chancellor of VSSUT Burla, our guest of honor, Professor Chinmoy Saha from the Indian Institute of Space Science and Technology in Kerala, Dr. R. Nagaraja, C.M.D. of PRDC Bengaluru, Dr. Jayashree Dash, our Dean Research, and Dr. Biranchi, Rath, who is the organizing chair of this conference. I take this opportunity to welcome all those who are present here and all those who have joined from various locations to our live broadcast. I'll say a few words about Silicon. Silicon Institute of Technology, Bhubaneswar, was established in the year 2001 with a mission to impart quality-based technical education to all segments of society. Over the past couple of decades, it has grown to be one of the premier educational institutes in India with a proven track record of excellence in academics and a vibrant research culture. It has carved a unique niche place for itself in the academic map of India, and its prowess is now well known. We have achieved some significant milestones over the past 2 decades. We are an autonomous institute, having been granted academic autonomy by UGC in May 2018. We were ranked within the top 200 engineering institutes in India for 3 consecutive years by NIRF till 2022. This year, we are ranked in the band 151 to 300 in the innovation category. Also, 3 of our undergraduate programs in CSE, EEE, and ECE are accredited by NBA. This means that we adhere to the strictest standards of outcome-based higher education of uncompromising quality. Silicon is also accredited by NAC with a grade A. We adhere to a 5L quality policy of lectures, laboratory, library, learning, and leadership. We are continuing to develop our superior infrastructure, including technology-enabled lecture theaters and discussion rooms to help with the dissemination of knowledge in comfortable settings. Qualified and experienced faculty is supported by a well-equipped digital library and numerous labs for applied sciences and engineering. Silicon offers 6 undergraduate and 9 postgraduate programs, mostly in the circuit branches. BTech programs are offered in computer science and engineering, computer science and technology, computer engineering, electronics and communication engineering, electrical and electronics engineering, and electronics and instrumentation engineering. Postgraduate programs are offered in MCA, MTech in CSE, EEE, EC, MSc in data science. This year, we have introduced 3 additional MSc programs in VLSI, molecular medicine, and embedded electronics and IIoT. We have also started our own PhD program a couple of years ago in various disciplines with an enrolled strength of over 40 PhD scholars. Our outstanding academics typically result in excellent placement statistics for us. A majority of our students get employed before they graduate, and a good number with significantly enhanced packages. We also have a unique practice school program in the final year of BTech, which is an innovative internship concept in undergraduate engineering education. It creates a bridge between conventional classroom learning and gaining valuable real-life experience in an industry or research organization. We have tied up with a number of IT product and core companies over the past couple of years in rolling out this program. In India, where the major thrust is on technological advancement, it is absolutely imperative that we provide platforms for the rapid dissemination of knowledge, exchange of ideas, innovations, and sharing of experiences. This international conference is focused on high-quality research in different areas of circuits, power, and intelligent systems. This forum will be a confluence of eminent academicians, researchers, and industry persons from within the country and abroad, and will highlight some of the facets of technology that are currently at the cutting edge of research. Silicon, being an integral part of the technical community, has collaborated with IEEE and has taken the initiative in hosting this conference. IEEE Kolkata section, IEEE Bhubaneswar subsection are our technical sponsors. Many thanks to them and all the other sponsors for supporting us in conducting this conference. The 6 tracks and sessions of this conference have been designed to include the major thrust areas of interest, including microelectronic circuits and systems design, network and distribution systems, multimedia and signal processing, communication networks and IoT, power, energy and control, and intelligent systems and applications. The focus is on multidisciplinary, visionary, and futuristic research. A strong team of reviewers and program committee members have tried to include the very best of articles in this conference. So I would like to thank the participants for joining us from various parts of our country and abroad. This conference has gathered some of the foremost experts, researchers, and professionals in the fields of circuits, power systems, and intelligent technologies. It's a matter of great privilege for us to have such distinguished speakers from different domains and geographically dispersed locations. I would like to take this opportunity to thank the conference organizing committee for their diligent work and our technical sponsors for making this happen. I'm convinced that this conference will be a truly enriching experience and the takeaway will be immense for all the participants. I hope that all of you have a meaningful experience, and I wish our visitors who are here that they have a very pleasant stay in our temple city. Thank you.
Thank you so much, sir, for the welcome address. Now, as we proceed with the conference, I'd like to introduce our pardon me just a second. I'd like to introduce our General Chair, Professor Dr. R. Nagaraj from PRDC Limited. Professor Dr. Nagaraj is currently working as a Managing Director, PRDC Consultants Private Limited, Bengaluru, India. He's completed his bachelor's in electrical and electronics engineering from Mysore University and obtained his master's degree from Indian Institute of Science, Bangalore. And he has specialized in computer applications, power systems, and drives. He was awarded his doctorate for his work titled Development of Algorithm for Applications in Energy Control Centers by Indian Institute of Science, Bangalore. He started PRDC Private Limited at Bangalore in 1994. He's the brain behind the architecture, design, and development of MyPower, a power system analysis software, which is PRDC's flagship product, widely used by electric utilities, industries, consultants, universities, engineering colleges globally. His specializations include parallel computing, power system analysis, simulation, SCADA systems, and energy management systems, development of algorithm for real-time power simulation and control, power engineering education, and power system protection. Dr. R. Nagaraj has authored several technical, in fact, numerous technical papers and conducted a number of workshops, conference, seminars throughout the world. It's indeed a matter of honor and privilege to have him amongst us as a part of this conference from the very beginning. Sir, I'd like to welcome you here for your address, please.
Very good morning to all. At the outset, I would like to welcome all the dignitaries for this conference as General Chair of this CCPIS 2023, dignitaries on the dais, and also the dear students. It gives me immense pleasure to be part of this CCPIS from last almost 1 year. When Professor Panda called me that I should be the general chair, I told him that actually, yes, as long as actually the front runners and also the fielders are good, I can be a good goalkeeper. Because always in a football or the hockey field, if the ball is on the other part of the court, I don't have any work, correct or not? As a goalkeeper, we don't have any work. In fact, that is what I have been seeing. Of now and then, there was some communication, but otherwise, the entire team has conducted and organized this in terms of the selection of the papers, in terms of the various other activities. Therefore, as a general chair, yes, I'm a showpiece here, but definitely I think the institute had done a great job. My association with the institute is more than 15 years. We have the annual program here and in the electrical department. And every year, I think, but for 1 or 2, when I was not in the country, I was always part of that program and happy to get associated with the electrical department and also the Silicon Institute of Technology. Coming to this conference, if you see, it talks about the circuits, power, and also the intelligent systems. If you look at an electric vehicle also today, it has got an intelligent system. It has got actually the power, electric power, and also the circuits. What should be the outcome of this conference, therefore? Outcome of this conference we were talking about the innovation, indigenization and all, whether actually all the departments can put their hands together to come out with one automobile industry in the state of Orissa. Innovation within Orissa. If you look at Bhubaneswar city, within 100 meters in the city of Bhubaneswar, within 100 meters you come across a temple. That is why it is called temple city. I don't call Orissa state as a temple city, not at all. I'm calling it as an industrial hub. Why? Less than 10 kilometers, you are going to come across an industry. May it be a power plant, a HVDC transmission line. For example, Talcher Kolar, 2,300 megawatt. It's one of the biggest HVDC system in the country. Similarly, we have the steel industries. More than about 5, 6, all the major steel industries are in Orissa. Tisco Jamshedpur, Tata Steel is there, Bhushan Group is there. Bhushan has been taken over by JSW now. Rourkela Steel Plant, one of the premier steel plant set up by the Russian technology earlier. Therefore, within 10 kilometer stretch, you have got an industry. Orissa is actually first of its kind because it was the experimental hub for the World Bank projects. The privatization started, Patnaik is here, the OPTCL, maybe there are some friends from the OPTCL. The unbundling, privatization, everything started with the World Bank fund in the state of Orissa. You have a stable government, which is also equally important. Taking all these things into account, what should be the next step for the state of Orissa? You have got the power, you have got the generation, you have got actually the abundant manpower. Today, every household in Orissa has got a house in Bangalore. The children are working in Bangalore. The flights are full. Why? The lot of industries are there. Is it possible to move those industries here? The outcome of these type of conference should be to see that actually within the state, whether we can do some innovation, give the employment, improve the agriculture technology. These are the things actually should be the outcome of this conference. When we talk about the conference, each participant should get something out of the conference. If at all, for example, a practicing engineer, if he has got actually a burning problem, if it can be resolved, that is what actually he expects. For a practicing professor, if he is able to define a problem to a student, that's what he expects. For a research student, if he has got stuck and he is not able to find a path, a conference of this nature should be able to tell actually what should be the path, so that he will be able to wind up his thesis. For the young students, I think they're all from the 11th standard. That's what I came to know having my breakfast. For them, actually, they're in the dilemma. Should I take the MBBS or in the engineering? This type of conference, I'm also from IEEE. Therefore, I would like them to become young engineers. Fine, even the medical is also equally important. But actually, if they become young engineers, that is what the selfishness I have got if they're part of this conference. Therefore, for each and every participant of this type of conference, there is something taking away. Therefore, what we lack? That's the next question. I think while introducing me, they told I'm a professor. I'm not at all a professor. I don't know why I'm called a professor. But whenever I go to an industry, they call me as a professor. But actually, when I go to an academic institution, they call me that actually I'm from an industry. What is important is blending harmonization between the industry and also the academic institution. The peak demand of the Orissa is almost about 3,500, 4,000 megawatt. But actually the peak demand of all the industries hub put together within the state is more than 8,000 megawatt. And there is a type of generation that you have got also in the state. Thanks to OPTCL, they have handheld actually, including the distribution companies. Because it so happened in the state of Orissa that actually the privatization happened, all of a sudden, everyone ran away. Someone has to take care. OPTCL, your sponsor here, has taken care actually, all the distribution companies, they have hand-holded them. Similar to that, some of the industries should come forward and handhold actually the academic institutions. When that happens, definitely it is going to be a game changer. Therefore, as part of the general chair of this conference, I welcome you all, and I also want to thank all my colleagues and also the chairs of various organizing committees for making my life and also the job easy, so that actually we are able to get quality papers, quality audience, and also the quality speakers. Thank you very much.
Thank you so much, sir. That was indeed a very lucid explanation of our takeaway from this conference. I guess every one of us has something to take away from this conference and how to utilize this platform very effectively in our own respective work areas. That was much needed, sir. Thank you once again. Now, may I please request our organizing chair, Dr. Biranchi Narayan Rath, to brief the audience about the conference, what to expect, the modalities, and everything in brief about the conference. Sir, please.
Namaskar. Good morning, all. Welcome to this temple city for CCPIS 2023, technical course sponsored by IEEE. To be honest, I'm a bit nervous to stand in front of you and to say a few words on this occasion. But I'm equally grateful to the management, to all my head of departments, and the entire Silicon family for trusting me and giving this opportunity to be part of this conference as organizing chair. So I'm here to take you all through the journey of this conference, from where we started and how we reached. The idea of organizing an IEEE conference was initiated by the Department of Electronics Engineering and Department of Electrical and Electronic Engineering a year back. Subsequently, we got necessary approval from IEEE Bhubaneswar subsection and IEEE Kolkata subsection on 31st January 2023. Since this is the first IEEE conference organized by our institute as host, and to make it a grand success, we took the support from all the departments to organize this event. As a result, we have 6 technical tracks for this conference, covering all fields of engineering and technology in line of current industry trends. We, as a team, proposed and decided to have this conference in hybrid mode, online and offline, to have authors from all around the world to be part of this conference. As a result, out of the paper that we received, 22.5% paper we received outside India. Now coming to the statistic for this conference, the number of papers that we received is 354. Number of papers accepted is around 153. So that makes the acceptance percentage to be around 50% or within 50% as per IEEE standard and policy. Now, out of this 153 paper, 132 paper have been registered successfully by the author, and which mark the turnaround is to be right more than 85%, which is a huge win for us because we are conducting it for the first time. And to take you all, or to have you all a good experience during this conference, we try to reach eminent researcher to be our keynote speaker for this event, and we are honored to have them with us to deliver their talk during this session. Further, out of this 132 papers that we received, that will be presented through 19 technical sessions during this conference, orally, both in online and in offline mode simultaneously. Apart from this, we are going to have one interactive session which will be conducted by IEEE student chapter from our institute with eminent researcher within India and outside India. And with this, I hope you are going to have a good experience during this conference and your stay in this temple city, Bhubaneswar. Thank you all.
Thank you so much, Dr. Biranchi. Now proceeding ahead, we have amongst us our guest of honor, Dr. Chinmoy Shah. It's a coincidence or a matter of privilege, I do not know, when our country is making strides in the space. So it's indeed a matter of privilege for us to have such a dignitary amongst us, Dr. Chinmoy Shah. Before calling upon, I'd like to give a brief introduction to Dr. Chinmoy Shah. Dr. Chinmoy Shah is from Department of Avionics, Indian Institute of Space Science and Technology, Government of India. He was a postdoctoral fellow with Department of Electrical and Computer Engineering, Royal Military College of Canada, Kingston. He completed his PhD, MTech and BTech in Radio Physics and Electronics from University of Calcutta. He has served in esteemed organizations like IST, Swami Vivekananda Institute of Science and Technology, Kolkata, Jadavpur University, Heritage Institute of Technology, Haldia Institute of Technology, in the Department of Electronics and Communication Engineering. His research focus includes planar microwave circuits and systems, wireless power transfer, energy harvesting, feed antennas for satellite tracking applications, split ring resonators and their applications, engineered left-handed materials, metamaterials, printed antennas, ultra-wideband antennas, multifunctional antennas, bioelectromagnetics, and biomedical engineering. Is professionally affiliated to IEEE Kerala section, Kolkata section, IEEE AP, IEEE GRSS Society. Once again, we'd like to hear from our guest of honor, Dr. Chinmoy Shah. Sir, please.
Very good morning, and thank you very much for nice introduction. I respected Dr. Goutam Chattopadhyay, because of whom I am here. It's a kind of coincidence. He's from Jet Propulsion Laboratory of NASA, also from California Institute of Technology. Professor Talukdar, the principal of the college. Professor Majhi, the chief guest and vice chancellor of this institute. Professor Nagaraja, the general chair of CCPIS. Professor Narayan, the organizing chair. Professor Jayashree Das, the dean. And my dear participants, students, ladies and gentlemen. It's a privilege that I am here. I keep on coming to Bhubaneswar and Puri. I don't know how, But coming back to this conference, CCPIS, the Conference on Circuits, Power and Intelligence System, I think it covers a lot of things, a lot of technical areas connected with various societies of IEEE, as mentioned by the speaker before me. And this type of conference, I feel very energetic when I come to this type of conferences, because it is like an Olympic. You have so many tracks. It's not World Cup. It's not World Cup where you have Messi or Neymar, or it's not say US Open or other thing, but it's an Olympic where you have Usain Bolt, Michael Phelps, or something like that. What I want to mean is, in this type of conferences, you have more chances to interact not only with your peers, but with some of the other people who are working in technical areas which is slightly offset from yours, but that is the opportunity that gives you the opportunity to interact, to network, to collaborate, and to expand the horizon of our research. So this type of conferences we should attend some time, because we normally attend the conferences which are very much technically focused to our society. For example, we keep on attending the Antenna Propagation Conference or Microwave Theory and Technology Society Conference. And some of you must be attending similar type of conferences in your technical area. But if we go to this type of conferences like, Indicon, IEEE conference, which is run by IEEE India Council, or TENCon, which is run by Region 10, IEEE Region 10 conference. In this type of conferences, you have all tracks. So you have huge number of papers, huge number of participation. So here you have some kind of extra points where you can actually network, collaborate, and try to enhance, your technical areas and try to do some kind of exchange and etc. Now, the numbers which are told that 300 papers, and you had attracted and you have 50% acceptance with around 150 papers, and you have given the opportunity for both online and offline presentation, in-person presentation. This is good. This idea of online presentation came during the COVID time because people had real difficulty to travel. There was a lot of visa-related issue, etc. But just one point I would like to mention, that I chair the conference activity board of IEEE Kerala section. Probably you know that is the largest section across the globe. We are number 1 across the globe with close to 12,000 members. Beijing is second to Kerala. Here, from 2023 onwards, we have taken a decision that will not allow online presentation. That is because in conferences, you should come, you should interact, there should be networking. In some specific cases, genuine cases where there is travel-related issue, visa-related issue, etc., we should definitely allow. But otherwise, it is better that gradually we come back to the normal. That is, the conferences, one should come, one should present the paper, we should have more interaction, etc. Now, having said this, that this is a very broad conference covering to multiple technical societies, technical areas of IEEE, I would probably suggest that in future, you try to get some kind of technical sponsorship from the societies also, because that way your conference will grow further. Like in this case, we have circuit, power, and intelligence systems. So you have the opportunity to get the technical sponsorship from the Circuit Society, the Power Society, the PES, Power and Engineering Society, and probably from MTT Society also, and also the Computer System Society. It doesn't cost anything, but you gain a lot. You can bring some IEEE DL speakers in this conference without having any financial implication on you, because IEEE DLs, IEEE will take care of their travel and everything. So you get more number of resource persons, who can give invited talk, plenary talk, keynote talk and all, and your conference becomes more, appealing to attract more number of papers in future version. When I was interacting with Professor Shantanu yesterday, while coming back from airport, I was told that this conference is technically sponsored by IEEE Kolkata section. So probably in next version, we want to see, let Kolkata section be the technical sponsor, but we want to see more number of technical societies of IEEE also sponsoring this conference. We are here to help you out. Dr. Goutam Chattopadhyay is one of the key persons in MTT society, and we have very good connection with other societies also. I have my friend Dr. Sudhakar present over here. He has also a lot of experience. So we can actually help you out in growing the conference and take it to the next level. Another point I would like to mention that in this particular city of Bhubaneswar, now so many premier institutions are there. You have IIT, you have NIT, which is little far from here, but still it is in the same state. You have, Silicon, you have KIIT, you have IIIT, you have ISER, you have NISER, and I believe you have very good number of strength. And probably this is the time that Bhubaneswar should be a full section, because historically it was a subsection because of, long back, I was in Kolkata section, so I know the story and the history also. So probably sometime you can, all of you can sit together, you can discuss what is the number of strength you have in Bhubaneswar, what are the technical societies, student branch chapters, etc. you have, and you can have a networking meeting with all the people from different institutions, and probably you can think of having a full section, because that gives you more freedom, more flexibility, and more opportunities to hold a conference in a much bigger fashion. So you may just contemplate on this kind of thing. And finally, I was told that I am representing the space today. So again, coming back to the point that this is a diversified conference, and if you look at the requirement of space, or if you look at the total component involved in Chandrayaan-3, a successful soft landing on the moon, then you see almost all engineers, all societies of IEEE are involved. So ISRO, Indian Space Research Organizations, is an organization where every engineer, even every scientist nowadays, even physicist, material scientist, chemistry people, everybody has an opportunity. And in all sort of engineers, aerospace, mechanical, thermal, launch vehicles means it is more of aerospace people. And then when you are talking about communication, almost everybody is needed. So, we are actually a family where all engineers and all scientists are involved in a particular fashion. And I'm privileged to be part of Indian Space, Department of Space, because we have a very strong rapport with different centers of Indian Space Research Organization. I personally have project with, EASTRAC, which is ISRO Satellite Tracking Center, then NRSC, National Remote Sensing Center, Hyderabad, and so on. A good rapport with Space Application Center, Ahmedabad also. And finally, before I conclude, I just want to mention one more point. I was giving more emphasis on conferences which are having very much more technical focus, but I also mentioned that you need to have this type of conferences where you have the opportunity to intermingle and to make new friends with other societies. So we have a conference which is happening every year, every December, which is called MapCon, Microwave Antenna Propagation Conference. Some of the models that we have incorporated in the conference you might think of. We have a mentor-mentee program where we allow the students, mainly the young students and young faculty members, to interact with the seasoned people, with experts, in an informal session. In a hall, we have other students who want some idea, who wants to get some suggestion on the problem. Somewhere maybe they are stuck, or they have some kind of confusion on communication, etc., etc. So we create this type of opportunity, a couple of hour session where there is a kind of opportunity for the students, and also not only to solve their current problem, but also to get an idea on the future steps. Sometimes such session has given a direct opportunity to get a postdoc position or to get involved in a work remotely. So this kind of thing probably you may think of in future. And other kind of sessions like YP, young professional session, then special women session for women in engineering, because uniform growth and the diversity and inclusion is one of the motto of IEEE. So we should see that we have an equal representation in all of the things from our female counterparts also. Okay, so these are the few points probably you can do. And we are really impressed to see the numbers. You have 50% acceptance, and you have around 35% papers registered over here. And I sincerely believe that this conference is going to run for several years, because when a conference runs for several years, it becomes a very famous one. And sometimes the institute becomes also very well known and famous because of a successful conference, because when you bring stalwarts like Dr. Goutam and other people, which you can bring in future version, as I mentioned, through IEEE schemes, IEEE DLs, and etc. So your conference is going to flourish, I am very sure, and I wish all the best to the organizers, to the participants, to the presenters, and I believe you'll exchange ideas. You'll not just present your paper and go to the beach. You should go to beach, and you should see the temple also, but make sure you talk to your friends, colleagues, and interact, and the ideas will be percolated, and you'll get and your research and your perspective will be enriched. Yeah, thank you very much. Thank you.
Thank you so much, sir. We'll definitely look forward in the same direction and would also seek your support in the same in our endeavor to achieve your directives. Thank you so much, sir. Thank you once again. Today we have an academician par excellence amongst us as our chief guest, Dr. Banshidhar Majhi, Vice Chancellor, VSSUT. Uh, as such, Professor Majhi doesn't require any introduction in the academic circuit, but as a formality, I'll be introducing Professor Dr. Banshidhar Majhi, who has extensive teaching and research experience spanning over 30 years. He's completed his PhD, his MTech in CSE and MCA from erstwhile REC, which is NIT Rourkela. He has served in various capacities in NIT Rourkela and was also associated with IIIT DM Kanchipuram, IIIT DM Kurnool in various administrative positions as well. He has also been part of eminent national accreditation committees like NBA, AICT, and NAC. He has handled various sponsored projects sponsored by ISRO, DIT, MHRD, Government of India, PXC Chandipur as the principal investigator. He has many patents and numerous research publications in various journals of repute. His research interests include image processing and computer vision, data compression, security protocols, parallel computing, soft computing, and biometrics. Among several other awards, Dr. Majhi is the recipient of prestigious Samanta Chandrasekhar Award for his outstanding contribution in engineering and technology from the Government of Orissa. So without much ado, I'd like to request Professor Dr. Majhi to address our audience. So please.
Good morning to all of you. Honorable dignitaries on the dais, Professor Talukdar, the principals of SIT Bhubaneswar, Dr. Nagaraja, General Chair, CCPIS 2023 from PRDC Bengaluru, Professor Rath, who is our own student at NIT Rourkela, happy to see him here, the organizing chair, Professor Saha from the IAST Thiruvananthapuram, Madam Das, Dean Research, SIT Bhubaneswar, our esteemed guest from NASA, Professor Goutam, Dr. Goutam, and Madam Namerita from NXP Semiconductor, and esteemed faculty members, dear participants, and young minds sitting on the right side, signing across, and ladies and gentlemen. It is indeed an honor to be here on this CCPIS 2023, organized by Silicon Institute of Technology, co-sponsored by the IEEE Bhubaneswar subsection. And in fact, it is an honor, and I'm delighted due to many folds. First of all, I'm able to meet many of my students, those who are pursuing their career in NIT Rourkela, and happy to see. The second reason is that I've been associated with SIT, Silicon Institute of Technology, from the nascent stage way back in 2000. And I'm very happy to see that the institution has grown up to be a knowledge hub and doing the institute or imparting the education par excellence. And in fact, the third one is like the whole conferences I'm seeing being organized by the students themselves, and they're trying to put their level best effort to make this as good as possible. And even in fact, when I was listening to this, the first song and the second one, I was in fact seeing whether it is actually being played from the machine or they are actually playing. So nice and so talented guys. This conference, CCPIS 2023, is an unwavering commitment towards the research fraternity. And I'm sure the conference exploration will hit an astounding milestone with the imminent mission of this particular conference. And this has become a platform. In fact, as I am seeing, they have tried to congregate so many eminent people And also they have not left even to the school kids who will take the advantage of this particular conference. I'm sure the event will be an immense success and boon for all the participants and the speakers as well. The sessions will be absolutely interactive during this next 2 days and will involve the intellectual question hour sessions. And I'm sure the experts will resolve the queries of our participants. In fact, when we say like, when a student came and asked to a senior personality, to a sage, sir, what is knowledge? In fact, the sage looked at him and then enigmatically replied, what you know, you hold to serve, that is knowledge. What you do not know, you hold to learn, and that is knowledge. And that knowledge is the process of constantly learning from each other and taking to a new horizon. And I think this is one of the such wonderful event that is being thought by the Silicon Institute of Technology, so that many people, the experienced, the learners, the faculties, the students, they will try to learn from each other's experience and try to enhance their knowledge to a newer directions. The theme which is actually being thought of, the circuits, power and intelligent systems, is an utmost importance. And even if like wherever you go now, people are talking about AI, machine learning, intelligent systems, and across, you tell me an application where AI has not been embedded into. But at the same time, we have to also learn why AI has come. In fact, this AI was there way back in 1960s, 1970s. But practically now it is possible to explore more because of the advent in the technology, in the power of computations. And whether we talk about deep learning, whether you talk about machine learning, when we are dealing with a very large amount of data, the computational power plays a very, very vital role. And there our circuits or the technology of semiconductors comes into the picture. So when we think that one technology is adventing, there are a lot of things behind it. So every technology has to be given an utmost importance. And that is what, and similarly, the power is also one of the very vital factor we are talking about now. And in fact, when we say, and a lot of good things are happening during the last few days, Professor was talking about the Chandrayaan-3 mission. In the sports, we have achieved something, a milestone. So a lot of good things are happening in our society, in our India, and for which we are proud of. And in fact, again, to manyfold, it has increased from the institute where I am leading. As many of 14 people have contributed this, my alumnus, almost 14. And I will tell you the reason of telling this, why I am saying there are people who have passed out from 1986, 87, and there are people even who has passed out in 2021. My objective of talking to you is that innovations can come from across. Innovations or the research can come from across. And in fact, I strongly believe during my last 30 years of experience, it mostly come from the young minds like our BTech boys and the young kids, even studying at the school level in the higher secondary level. So the objective is talking about and who drives these particular systems. At this particular juncture, I want to talk my students, my faculty colleagues from Silicon are there. As the NEP says that the faculty is the major potential for any educational institutions to drive. And their contribution matters a lot to drive these young minds at the undergraduate level or the further younger level. So we all have to work together. And this is such a forum where we exchange our ideas, thought process, so that we learn from each other and take our knowledge spectrum to a different life. I wish, I sincerely congratulate Silicon Institute of Technology and organizing team for making this, to organize such a conference. But conference, normally we attend, we listen, then we go back. But this is also a forum where the connectivity must go on. We must connect to each other so that the research or our ideas can be exchanged for the time to come, or many more time to come. I'm sure the participants will adore this conference and also find time to release this beauty of Odisha, already pointed out, whether you talk about industrial hub Odisha or temple city or temple state Odisha. So I wish all the participants that this conference to be academically fruitful. Thank you very much.
Thank you so much, sir. And like it is ironical, the definition of the sage regarding the what is knowledge or definition of knowledge is ironical to what we are in our endeavor for the next 3 days. So we hope to make the most out of it. All the participants, all the attendees, we faculty members, researchers, let's in tandem with the definition of knowledge, make the most out of this conference. Thank you very much, sir, for that. Proceeding ahead with the inauguration, but before we start with the rest of the part of the inauguration, I'd like to request all our audience to give a huge round of applause for all our dignitaries. I'd like to request our volunteers to please bring the conference proceedings and request our dignitaries to please release the conference proceedings of CCPIS 2023. A round of applause for that. Thank you, sir. Thank you, ma'am. Now, as we come towards the end of the inauguration ceremony, we'd like to extend our respect for all our dignitaries on dais with the felicitation of our guests, our guest of honor, our chief guest, our organizing chair, our general chair, our principal, and our dean research. So for that, I'd like to request our principal, Dr. Jaideep Talukdar, to please felicitate our chief guest, Dr. Banshidhar Majhi. Thank you, sir. I'd like to request our organizing chair, Dr. Biranchi Narayan Rath, to felicitate our guest of honor, Dr. Chinmoy. Thank you, sir. I'd like to request our Dean Research, Dr. Jayashree Das, to felicitate our General Chair, Dr. R. Nagaraj. To appreciate the relentless effort that has been put year-long by our organizing chair, our principal, and our dean research, I'd like to request our chief guest, Dr. Banshidhar Majhi, to felicitate our principal, Dr. Jaideep Talukdar. Sir, please. Sir, please. I'd also like to request Professor Majhi to felicitate our organizing chair, Dr. Biranchi Narayan Rath. So you'll have to stay back a bit more. To appreciate the year-long relentless effort in the back foot, I'd like to request Professor Majhi to felicitate our Dean Research, our Dr. Jayashree ma'am. Thank you so much, sir. Thank you. As we come to the end, before ending, I'd like to request our Dean Research to propose the vote of thanks for inauguration ceremony. I'd like to request Dr. Jayashree Das to please come to the podium for the vote of thanks.
Thank you, Sushri. Respected dignitaries on the dais and off the dais, esteemed speakers, delegates of the conference, my colleagues and students. Good morning and warm greetings to this grand event of the International Conference on Circuit, Power and Intelligence System at Silicon Institute of Technology. CCPIS 2023 is a 3 days conference. It has been organized with the noble aim to provide a platform for the leading academic and industrial scientists and researchers to exchange and share knowledge, ideas, and experiences in the field of circuit, power, and intelligence system in a beneficial way of its participants. Indeed, it is a proud honor for our institute to host the prestigious IEEE International Conference, and we are all committed to organize this conference nicely, flawlessly, and make it memorable for all. On this occasion, I take the opportunity to thank all the people who have been instrumental in organizing this conference. Sincere thanks to the Silicon management and trustee members for providing support for the event. We are grateful to our chief guest of the event, Professor Banshidhar Majhi, Vice Chancellor, VSSUT Burla, and our guest of honor, Professor Chinmoy Saha, Associate Professor, Indian Institute of Space, Science and Technology, Thiruvananthapuram. Thank you, sir, for gracing the occasion with your august presence today. We have the privilege of hearing to 6 eminent personalities from reputed organizations during these 3 days of the conference. Our esteemed keynote speakers of CCPIS 2023 are Dr. Goutam Chattopadhyay from NASA Jet Propulsion Laboratory, US, Dr. Ramappa Nagaraja from PRDC Private Limited, India, Dr. Bhaskaran Raman from IIT Mumbai, India, Madam Namerita Khanna from NXP Semiconductors, India, Dr. Satya K.Vankayala from Samsung R&D Institute, India, Dr. Sandeep K. Shukla from IIT Kanpur, India. We thank them all for their kind consent to enlighten the participants with their valuable knowledge and vast practical experiences. Sincere thanks to the entire organizing team, comprising of the General Chair, Professor Vincent Oria, New Jersey Institute of Technology, USA, Professor Ramappa Nagaraja, PRDC, India, Professor Ramprasad Panda, SIT Bhubaneswar, India. The program chairs, Professor Samir Sankusale, Tufts University, USA, and Professor Saroj Raut, SIT Bhubaneswar. Organizing Chair, Professor Biranchi Narayan Rath and his team. Technical Chair, Professor Sudhanshu Mohan Bishwa and his team. Web Chair, Professor Samaleshwari Prasad Naik and team. Publicity Chair, Professor Tapas Kumar Majhi and team. Finance Chair, Professor Biswajit Baral and team. Sponsorship Chair, Professor Sanjit Swai and his team. Publication Chair, Professor Pradyumna Kumar Tripathi and team. Registration Chair, Ms. Devangana Das and team. Local Organizing Chair, Professor Soumya Ranjan Samal. All the members have done excellent job with untiring effort to make this event a grand success. Heartfelt thanks to each of them. Sincere thanks to our director, Dr. Sarojkanta Mishra, Principal Dr. Jaideep Talukdar, and Dean Academics Dr. Debabrata Kara for their continuous support and timely advices. Today, the event has come to this stage of execution because of an incredible dedicated local organizing team of the faculty members from electrical and electronics engineering departments. Along with their usual academic and administrative loads, the team members have worked hard day and night for the last couple of months to put all their efforts to make the event successful and memorable. Thanks to all the members. We are thankful to the team of student volunteers, vendors, photographers, all non-teaching staff, floor assistants, electricians, and media persons for their valuable helps. Thanks to all staff of Silicon Institute of Technology, Bhubaneswar in general, for providing all possible logistic support in organizing this event. Heartfelt thanks to all the participants and delegates attending the conference for the coming 3 days. This event would not have been possible without their active participation. Thanks to the researchers who will be appraising the participants with their valuable research findings through paper presentation. Special thanks to the sponsors of the event, IEEE Kolkata section, IEEE Bhubaneswar section, PRDC, OPTCL, CodeBeat, ITW, Logic Jap, STL, and Jindal India Thermal Power Limited. Many people have contributed for the smooth conduction of this highly acclaimed international conference. It is not possible to mention all the names here. Sincere thanks to all who have directly or indirectly associated with the event. Thank you all for being a part of this conference. I wish the event a grand success. Thank you.
Thank you so much, ma'am, for proposing the vote of thanks. Actually, we have clubbed the first keynote speech session with this inauguration event. So as we go for the end of this inauguration ceremony, we'll be immediately starting our keynote 1 speech. So do you have any concerns? Okay. So we'll take after 2 minutes, we'll be starting our keynote 1 session, which will be delivered ironically by Dr. Goutam Chattopadhyay from NASA Jet Propulsion Laboratory. So I'd like to request Lopa ma'am to please introduce our keynote speaker.
Good morning, ladies and gentlemen. It is my honor to welcome and introduce the keynote speaker of session 1, Dr. Goutam Chattopadhyay, Senior Scientist at NASA's Jet Propulsion Laboratory, California Institute of Technology, USA. He was a distinguished visiting chair professor at the Indian Institute of Science, Bengaluru, and an adjunct professor at the Indian Institute of Technology, Kharagpur. He received his BE degree in Electronics and Telecommunication Engineering from University of Calcutta in the year 1987, MSc in Electrical Engineering from University of Virginia in the year 1994, and received his PhD in Electrical Engineering from California Institute of Technology, Pasadena in the year 1999. He has more than 350 publications in the international journals and conferences and holds more than 20 patents. He received the IEEE Region 6 Engineer of the Year Award in the year 2018, Distinguished Alumni Award from Indian Institute of Engineering, Science and Technology in the year 2017. He has received NASA Group Achievement Award in the year 2005, 2007, 9, 11, 2014, and also he has received JPL Mariner Award in the year 2013. He was the recipient of the Best Journal Paper Award in the year 2020 and 2013 by IEEE Transaction on Terahertz Science and Technology, Best Paper Award for Antenna Design and Application at the European Antennas and Propagation Conference UCAP in the year 2017, and IET Professor Biman Bihari Sen Memorial Award in the year 2022 and Professor S.N. Mitra Memorial Award in the year 2014. Most recently, he was recognized by US Consulate in Kolkata as a part of 9 Asian American and Pacific Islander contribution to science, technology, and society. His research interests include microwave, millimeter wave, and terahertz receiver systems and radars, and development of space instruments for the search for life beyond Earth. I welcome once again Dr. Chattopadhyay to present his talk on the topic radars and metasurface antennas at the millimeter waves. Please, sir. Now I request the student volunteer to present a bouquet. So please welcome Professor Chattopadhyay with a huge round of applause.
Can I move around? What? What? If you want, you can use one. Ready? All right. Okay, good morning, everyone. I'm really excited to be here. Someone asked me that what excites you most? I told that person that when I'm among students, that's when I'm mostly excited, because the students and the young professionals, the young minds, they are the one are going to take us forward to the next level, right? And when I talk to them, I get so much more from them than they get from me, because the question that they ask is much more innovative. You can never even think about that. And they will ask those questions, and that makes you think. So I'm really excited. So you can see that I actually changed the title of my talk. Originally, I was going to talk about radars and metasurfaces and antennas. So those are mostly somewhat more technical in nature. Instead, I thought that looking at the audience, maybe it'll be a good idea to talk about some of the NASA instruments and science that we do. Of course, in a half an hour talk, you cannot cover all the instruments that we are developing at NASA. So what I'm going to tell you today is giving you a flavor of what we do and what kind of instruments we are building and why we are building those kind of instruments, what we do at NASA. And again, I want to thank one of my colleague, Shantanu, for inviting me here. He has been contacting me over LinkedIn for a long time that I should come here. As a matter of fact, I came to India last week. I stayed at home. My hometown is Kolkata. I stayed there for only a couple of days. My mother is very upset because of that. Since then, I have been traveling. Of course, I get invitation from a lot of places around the globe and within India from IITs, but I prefer to go to other places. And there's specific reason for that, because there are talent everywhere in the globe. If you can, someone asked me, what is the reward or award that you aspire to get most? The only reward or award that I aspire to get is if I can excite one mind to do something big. That will be the biggest reward. And that's why I actually go around and talk to students, young professionals. I went to NIT Silchar, and from there I went to NIT Meghalaya, to Shillong. 9 hours of drive we had through treacherous roads, but it was worth it. And I'm here, actually, we arrived here late last night around 10:30, and I'm here in the audience among you all. So let's talk about NASA science. If you notice the background of my talk title, there's very specifically, I chose this one. It shows a young girl just stepping into Mars. Of course, this is fake. This is not ChatGPT generated, but it actually symbolizes the inquisitive mind of our youth. And that's why, and particularly for girl students. So it's very, very important that we encourage them. That's why I chose this. I want to acknowledge my team. I am from NASA Jet Propulsion Laboratory. NASA has different centers across the United States. So JPL is one of the labs, the largest lab of NASA. We do all robotic missions. So the news that you hear from Mars, that rover on Mars or the helicopter on Mars, that we develop in our lab. It is a somewhat large lab. We have about 6,000 people. So I lead one of the group called Sub-millimeter wave advanced technology group. One of the reasons I'm showing all these pictures is because if you look at the faces, you'll realize that they come from all over the globe. So whatever success we have at NASA, I believe that is because of the diversity of people that we have, the diversity of people, diversity of ideas, and the diversity of thoughts. And that makes us very unique. And that's how we can make, the progress. So let's start with the Big Bang Theory. This is not the Big Bang Theory you watch on TV. This is the real Big Bang Theory, because scientists believe that our universe started with a Big Bang about 13.85 billion years ago. And currently we have the universe that we have, where all the stars and galaxies that you see. But if you look back in terms of radiation, many of us actually work in electrical engineering and electromagnetics. We always look into the radiation aspect of it. The first light of this universe came out about 400,000 years after Big Bang. So there was no light in this universe when the universe was created. And this was discovered in a very unique way. Two scientists from AT&T Bell Labs in New Jersey, they were doing some communication experiment. And whenever they were actually using the receiver to receive the signals, they were finding some extra noise in their receiver. And wherever they're looking, they find that extra noise, and they are not able to understand where this extra noise is coming from. So then they went and talked to one of the physicists, and that physicist told them, you should look a little bit more carefully. Maybe you are looking at the first light of the universe. And guess what? They actually went back and they realized they were looking at the cosmic microwave background signal, the first light of the universe. So many of you do experiments in your lab, and sometimes you cannot explain some of this stuff, right? So next time, if you cannot explain something in your lab experiments, do not think that it's some kind of experimental error. Because those two gentlemen, they were initially thinking maybe there's experimental error, but they went on to find out the first light of the universe. They got Nobel Prize for that. So if you also just don't say it's experimental error and then put the error bar a little larger, maybe you get the Nobel Prize one day, who knows? So what do we do at NASA? This is a big question that people ask me. What we do at NASA is actually do science. We are an institution for science. We are trying to answer big science questions. One of the biggest science questions that is actually intriguing to all the human beings is, are we alone in this universe? Is there life anywhere else outside of planet Earth? So let me set the stage, set the stage very well. We have not found any life anywhere outside our planet Earth. Whatever you see, whatever you hear on internet about the aliens, we have not found any life. We have not found a single cell outside our planet Earth. If someone says that they have found some aliens, please ask them to talk to us. We'll be very much interested in talking to that person, because we are also doing that business. Why shall we spend billions of dollars trying to find a single cell somewhere where someone has already found an alien? But the question that people ask, okay, we have not found anything. Is there really life outside our planet Earth? This is a big question. They ask me. My answer to that is, there is possibility of life outside our planet Earth. Why do I say that? That's because if you look in the sky, in the dark sky, when you look up, you'll see thousands and thousands of stars. You know how many stars are there in our own galaxy, Milky Way galaxy? About 100 billion, order of magnitude. And in our universe, we have about 100 billion galaxies. So do your math. We have about 10 to the power 22 to 10 to the power 23 stars in our universe. And we are finding majority of those stars, they have planets around them. Not just one, multiple planets around them. So the question is, what is the probability that we find one such star and one such planet where the conditions are such that life can exist? That probability has to be non-zero. And that's what we are trying to find. We are trying to find those planets where life can exist. And so far, we have found about, they're called exoplanets, those planets. We have found about 5,000 plus exoplanets. And many of them are, the conditions such that life can exist. So what kind of conditions need to be there for life to exist? When we are looking for life, we are looking for our kind of life, hydrocarbon-based life. You might say, that could be other kind of life. Answer is yes, that could be other kind of life. How do you search for them? What do you search? Because we know how our kind of life looks like, we can search for those kind of life. We can find some other kind of life, but we cannot actively search for that. So for our kind of life to exist, we need water. We need oxygen, the hydrocarbon-based life. So the planet has to be a rocky planet. It cannot be a gaseous giant like Jupiter. And so we call some of this planet called in the habitable zone, where the temperature is such that water can exist in the liquid form on the surface. That's what we are looking for. And we already found many such planets. Problem is, we cannot really go there. One of the nearest planet that we found
is 4 light years away. It will take 40 million years for us to reach there. So we cannot go in our lifetime. So we'll have to develop technologies to learn more about it. And that's what we are doing. That's what NASA is doing, developing technologies to actually find out what we can learn. So how do we find this kind of planets? That is the first question, right? One of the way to do that is called this method called transit time method. So look at this. This is a star, and we believe there is a planet around it, let's say. If you can isolate the total amount of light that is coming from that star, and then you measure the total light that is coming in, if there is a planet around it, as the planet goes around that star, it comes in front, there is a little bit of dip. If I can find the cursor, okay, there is a little bit of dip here that you can see. And from there, we can say, yes, there is a planet around that. And not only that, by studying the time it takes, you can learn so much. You can actually deduce what is the size of that planet, how far that planet is from that star. And then from there, you can find out what's the density, because you can do all the calculations. Is it a rocky planet? Is it a gaseous planet? You can actually deduce so much more about all this stuff looking at this. And that's what we do. Only problem is you can see that if you're looking at really far off star, total amount of light that will dip will be so minuscule that your instrument has to be extremely sensitive. And that's where we are lacking right now, because we do not have that extreme sensitivity to detect all this from farthest of the stars. That's why I'm talking to you all. Come and join us, help us develop those new technologies so that we can actually look far beyond. So you can ask me, I said, there are 100 billion galaxies, 100 billion stars in each galaxies. There should be trillions and trillions of planets around us. We have found only 5,000. Why? Because we have not looked far. If you look at this is our Milky Way galaxy. And so far you have looked into only in a narrow region of our own galaxy. That's because that is the technology we have. So we can find many more such planets, and we'll be able to find life. That's what we are doing. Okay, those are far off places. It takes light years. Is there possibility of life in our own neighborhood, in our own solar system? The answer is yes. This is what you are seeing here is Saturn has a moon called Enceladus. Enceladus is a very cold planetary body. It's kind of ice. What you are seeing here is that actually water gushing out from Enceladus. So we actually detected this using an instrument called Hi-Fi instrument on Herschel Space Observatory. And fortunately for me, I was involved in developing that instrument for Hi-Fi. And that actually detected for the first time that water is gushing out from one of the planetary bodies. Why this is interesting? Because if there is a cold planetary body and water is gushing out, it must have a source of energy that is making the water liquid. So if there is water, if there is energy, is there life? That is the question. What else is coming out other than water? We don't know. We have not much knowledge about it. So NASA actually is planning a mission to go to Enceladus and see, is there any organic materials coming out of that? Organics does not necessarily mean life, but is a precursor to life. So we are actually developing instrumentation to do that. And it's very exciting. One more thing I want to talk about here is that, if you go to Saturn, because this is the moon of Saturn, Saturn doesn't have any source of water. If you go to some of these moons of Saturn like Titan, you'll see beautiful lakes there, blue, beautiful lake. But they're not made of water. They're made of methane. They're methane lake. So we were finding, some of the scientists were finding there is water vapor on the outer rings of Saturn. So they're all scratching their head and thinking, from where is water coming from? Because Saturn doesn't have a source of water. And guess what? This moon, that Enceladus, was raining water on Saturn. And because of the large gravity, It was pulling in all this water vapor. And that's how we actually detected water vapor on this. So science is very interesting when you start thinking about it. And once you actually find the answer to that, that's where the excitement happens. So we do not know whether there is life in Enceladus water or not, but we are actually going to send some instrument to find out. And that is happening soon. Another planetary body is very exciting is Europa. Europa is a moon of Jupiter. It is again a very cold planetary body, but scientists believe there is a liquid water ocean underneath the ice shell. So there is a thick ice shell here you can see. The thickness of the ice shell is about 100 kilometers to 15 kilometers. But there's a liquid water ocean, which means there is a source of energy, right? NASA is planning a mission to Europa. So if NASA came to you all the students and said, we are planning a mission to go to Europa, what kind of instruments you are going to build to find out if there is life? What will be your answer? What instrument are you going to build to answer that question? The obvious answer is we are going to send a drill a hole, lower a bucket, and see if there's any fish. I'm in Orissa, of course, we all are fish lovers. Problem is, it takes 7 years to go to Europa. And when we are sending an instrument to such a place, we have total about 400 watts of total power available. 400 watts is 4 light bulbs, 100-watt light bulb, right? What kind of drill you can send with 400 watts that can drill 15 to 100 kilometers through ice? It's not going to happen, right? So then you'll have to think. Then shall we say, oh, we cannot do anything? We'll sit on our back? No. That's why we need scientists and engineers like you to come up with new ideas. So we started studying and found that it turns out there are a lot of cracks in this ice shell. And the material actually seeps all the way to the top surface. But since it is so cold, it freezes. However, Europa is very close to Jupiter. Jupiter has a very high magnetic field. That means very high radiation. What the radiation does is sputters the material from the surface in the atmosphere. Now, if you have a very high resolution spectrometer, many of you know what a spectrometer is. If you're a student and if you don't know spectrometer, that means you have not studied in your 12th grade. On your 12th grade, there was an experiment that you did with sodium vapor lamp, that where you see a line, right? Sodium, all the atoms, as well as some of these, polar molecules, they have spectroscopic line because they vibrate at a particular frequency. And that's what we can detect. It turns out a lot of organic materials have spectroscopic lines in the frequency band of 500 to 1 terahertz. And that's what we are doing. We are building instruments to actually detect what else it will detect in the atmosphere. What are those materials that is coming out? Is there any organic materials? Is there any life kind of materials? Of course, we are going to send some instrument which will have a GPR, ground penetrating radar, and many other stuff. So NASA's mission for Europa called Europa Clipper is going to be launched in 2024, 2025 timescale. So right now we are all integrating all the instruments. When you come to visit me, I'll show you at the high bay, actually, we are currently doing the integration for that instrument. We'll find out what happens. Can we find life there or not? And the last thing that we keep going is Mars. Mangalyaan mission you must have heard about from ISRO. And we have been going to Mars for a long time. The question is, why do we go there? From scientifically, the reason is that Mars actually resembles so much like our planet Earth, at least in its early history. And also Mars is our closest neighbor. It's easy to go there. It still takes 7 months to go to Mars. So that's why you have been exploring Mars for a long time, and we have a lot of rovers going there and doing experiments. We started with a small rover, and then we sent the twin rovers. And then Curiosity was the one that we actually sent in 2011. And the latest one, you must have heard about Perseverance rover. you can see that with time, each of them actually grown bigger and bigger and bigger because scientists are very, very greedy. They want everything. So, but if you need more instruments, that means it has to grow. And it becomes more and more challenging how you can land something. You all, now everyone knows about Chandrayaan-3, Vikram and Pragyan. We are all so excited, right? Think about the challenges that to go to moon, to land on moon. NASA landed on moon in 1965, right? We sent human being there in 1969. But still, even now, there's so much challenges. So many things can go wrong, right? And think about that, taking one step further. We are going to Mars, another planet, so far away. This is the picture of the Perseverance rover actually in our lab. As I was telling you, the high bay. Right now here you will see that Europa Clipper. A couple of months ago, at the same place, there was an instrument being assembled called NISAR, NASA ISRO Synthetic Aperture Radar. We are actually jointly, we are building a mission called NISAR that will be launched next year. So it was here. Landing on Mars is extremely challenging. Many of you know that, we are not always successful. US has been the only country has been successfully landed something on Mars. You can send an orbiter, but landing is much more difficult because the atmosphere of Mars is only 1% of our planet Earth, the density of the atmosphere. As a result, you cannot slow down that easily. So you'll have to, a lot of very critical thing that you'll have to enter on the Martian atmosphere at a very particular angle, about 11 degrees. So next time there is a mission to Mars, just check, just pay attention that what angle they're entering in the Martian atmosphere. It has to be about 11 degrees because that's when you can get the maximum, friction to slow yourself down. And not only that, after you actually keep going down, you cannot use the thruster. Many of you know the Chandrayaan had used thrusters to go all the way down, right? You cannot do that on Mars. Why? Because Mars has a lot of big boulders, all the stones. If you're using the thruster to go all the way to the ground, then what will happen? It will take all this debris and it will actually blow up and hit your instrument and it will destroy it. You cannot do that. So we are all scratching our head how to solve this problem. Then someone came up with the brilliant idea that we will have a crane on Mars. Think about it. A crane from a kind of spacecraft hovering around and it will lower the instrument. Initially, it sounded crazy, but sometimes crazy ideas actually work. And guess what? We actually have used a crane to lower the rover on the Martian surface. And then the cords are cut and then the spacecraft flies away and the rover goes onto the ground. So for last 20 years, we have been very successful. We did not have any single failure. And fingers crossed, hopefully that will continue. Look at these photographs. They're actually from Mars. If I told you that they are all from our own planet, you say, yes, it looks so much like our own planet, right? Look at all of them. But if you pay close attention, what you are going to see is this terrain, this kind of terrain we get only when there is flowing water. Because look at these rocks, which means that at one point of time on Mars, there is flowing water. But if you go to Mars today, we don't see flowing water. We see water that is underground, but not much water. So what happened? Where did that water go? Can it happen to our own planet? And what can we do to prevent it? So these are the very big questions we'll have to deal with. And we are trying to understand from our neighbor that what happened to them. And we are actually sending instruments to learn about it. Was Mars ever habitable? Was there life on Mars at any point of time? Is there life on Mars today? So these are the questions we are trying to answer. And we cannot do all the experiments sitting on Mars. So we're actually doing sample collection, something called Mars Sample Return Mission for NASA is planning. So we are collecting samples on Mars. We are going to bring it back on Earth. So far, we have not brought anything back from Mars. We do not have the technology to do that, safely. Many people actually read some fake news that someone from India is going to be the first person landing on Mars or some stuff, right? I say, great, send them, because the technology that we have is a one-way ticket. We cannot bring them back. Now you can choose whom you want to send. I don't want to talk about politics. So another really interesting question that we grapple with is Earth's water. I'll talk about instruments next. This is the last slide about science. How many of you know that when our Earth was created, there was no water? Not many. Our youngest colleague in the audience, he knows. So actually that's true. When our planet was formed, there's no water. So the question is, how did water come? From where water came from? In our solar system, our planet Earth. This is a very interesting question, right? So we say, scientists believe that comets brought water to Earth. If I say that, as an engineer, as a scientist, you are going to tell me, prove it to me. How do you prove that? We should always ask for proof, right? You should never believe if someone says something. If I say something, don't believe, ask questions. You should show me the proof. So how do you prove that actually comets brought water to Earth? It turns out that water that we drink every day, all of you are drinking every day, is one kind of water. It's called H216O. Oxygen has different isotopes. The most stable isotope is 16. That is the most abundant water. But there are other kinds of water, H217O, H218O, HDO, one hydrogen, one deuterium, one oxygen also makes water. T2O, all of us know about heavy water that is needed for nuclear power plant, right? So if you take the ratio of abundance of different kinds of water that we have, it turns out our Earth's ratio is very similar to the sum of the comets. And if the abundance ratio is the same, the source has to be the same. Unfortunately, we have only made about 10 such measurements on comets. So it is not that statistically significant enough to say, yes, all the water was brought to Earth by comets. We'll have to do more experiments. And I am actually involved in developing technologies and making instruments to do that. So let's pivot and talk about technology and instruments. Start with that. So I actually came up with an instrument concept. I call it WhatsUp. It stands for Water Hunting Advanced Terahertz Spectrometer on Ultra Small Platform, because we are trying to answer the question, what's up with water? I think I was funded by NASA to do this work because of this acronym. So what we are trying to do is we do exactly that, measure this water ratio, abundance ratio, but in a small satellite, CubeSat, and small sat platform. I'm going to talk to students tomorrow because of a professor here. Your professor actually talked to me and asked me to talk to the students about CubeSat. Students can do CubeSat. So they are shoebox-sized satellites, very small. So we can make multiple of them, and they can go to multiple comets and do this measurement and answer this fundamental question. So many of you, as I said, shoebox-sized satellites, CubeSats. CubeSats go by the unit of measurement as U. 1 U stands for a cube of 1 centimeter by 1 centimeter by, 10 centimeter by 10 centimeter by 10 centimeter, just small cube. So most of the instrument that we can actually fit in for a CubeSat, it has to be slightly bigger, 6U, stand about 30 centimeter by 20 by 10. So many of, there are a lot of things, it can have its own propulsion. They can actually fly on their own. And of course, they'll have to have a lot of other stuff there. So we have actually developed CubeSat to go to other planets. The first one, called Marco, it went to Mars for a communication experiment. Because when we go to Mars, many of you know that when it went to Moon, even then there is a little bit of delay of getting information. It takes signal to travel about 11 minutes from Earth to Mars. So when our instrument is going down, rover is going down, we do not have any information what is going on. So what we did actually, we actually made a relay center with the CubeSats that as the instrument was going down, the spacecraft, it was talking to this CubeSat, and the CubeSat had a DTE, that is direct transmission to Earth and sending the data back. So that's how we can get information, at least almost live information that's coming back from that. Of course, the delay was there. So we can do that. And for that, we also made many other CubeSat-based instruments. This is one of them. It's called Rain Cube. It's a radar. Again, a shoebox-sized satellite. You can see here, but it had a very large antenna. This is a 50-centimeter antenna. So this is one of the things that we did, because when you're talking about technology, you'll be facing a lot of challenges. If you want to have a 50-centimeter antenna on a small CubeSat, how do you put that antenna in the small CubeSat? So we came up with a very new, innovative idea here. So this is the volume that we had is about 10-centimeter cylinder to put an antenna, which will be 50-centimeter diameter. So we came up with a foldable antenna, deployable antenna. You can see, I'll show you the video of this deployment of the antenna. So this is a mesh antenna. This is a spring-loaded structure. You just release the pin, and then the antenna deploys. You can see here in the lab. Sub-reflector, if you work with antenna, you know that sub-reflector, and there is a horn antenna here. This is a frequency band about Ka band, that is 30 gigahertz. So, and then it's working really well. Only problem, if you deploy it, you're gonna pull it back again. So we have actually launched it and getting amazing data. Is a radar instrument. And so we are actually building this kind of antennas to go to outer space. So also, if you're talking about antennas, many of you know that metasurfaces are nowadays a big term. Everyone is looking at metasurfaces. We are actually making antennas that is flat, very low profile. Look at this. This is actually a 3D printed antenna, metasurface antenna that we did in our lab. We also have a patent on that. That the thickness of this entire antenna is this much, about 1.5 to 2 centimeters. So all metal structure. So you can actually, it's like a piece of paper of metal that you can stick on the wall of your satellite that will act as an antenna. So that is the advantage of this kind of antennas. So you have to have new ideas and innovation to solve this problem. Otherwise, how do you put together an instrument that is so small, very low power? So the instrument that I was talking to you about, that what's up, I'll give a little bit of background. This is how the overall the block diagram of the instrument looks like. It's a 500 to 600 gigahertz. As I was saying, the different kind of waters that we are trying to detect, or using the spectrometer. We need to do a lot of innovative designs. One of the things is that 500 to 600 gigahertz low profile antenna that we did is a reflector antenna. We also did a low profile lens antenna there. And then this is the measurement of that. And another thing that you'll have to do, whenever you are building an instrument, you'll have to calibrate it. As I said, you are measuring the water ratios, right? Abundance of different amount of water. How do you know what is the accuracy of your measurement? Otherwise, it will throw you away, right? You won't be able to get the data right. So one of the way to do that is calibration, to do a and for this kind of instrument, you need a switch to a calibration. There is a technique called DQ switch radiometer technique. That's where you actually do the calibration. But unfortunately, you do not have a switch available at this frequency, which is low loss. You cannot buy off shelf. You cannot go to Amazon and buy a switch that is working at these frequencies, unfortunately. You'll have to design it. You'll have to come up with an idea. So we actually built a MEMS-based switch here. You can see here, this is a MEMS structure. And the switch is actually, there's an arm going in and out. This is under the microscope because it's so tiny. And this is the metal rectangular waveguide. The dimension of the waveguide is about 500 micron by 250 micron. I'll give you an idea of what that means. You know what is the thickness of your hair? A single hair is about 150 micron. So you are actually making a waveguide in metal that is the size of a hair. So you are cutting metal with a piece of hair. So that is the kind of techniques that you will have to do. That is the kind of challenges that you're facing. But it still works. It works beautifully. So if you have enough, engineering, then you can do this. You can do this kind of stuff. Also, we actually made using some other kind of techniques. This is called not a MEMS. This is a piezoelectric motor, and it works very well. You actually move a waveguide in and out, and then it works. And also, many of you are working at VLSI. I heard that there's a VLSI, study, course that you are starting right now. So VLSI is very important, and of course, CMOS, the technologies. We are using CMOS technologies that I call it the cell phone technology for space application, and that's where a lot of contributions can come from India. So you all should think about taking VLSI classes and learn more about it. One of the new area of VLSI is called SoCs. SoCs stand for system on a chip. Many of you do VLSI in the digital part, you do analog part, but you do mixed signal as well. So the mixed signal VLSI is one of the more hottest areas where you can develop SoCs, that entire system on a single chip. So what we have done is, here you can see a small chip stand here on only this area. And that is a 65 nanometer VLSI based SoC that we fabricated. We designed in our lab, but we fabricated at TSMC. Many of you actually can design your chip and get it done, fabricated at TSMC. Now India has a semiconductor initiative. Many of you know, a lot of money will be spent and a lot of effort. You should all get involved into that. Can you do the design aspect of it? We need to do fabrication as well, but it will take not 100 billion. It will take a few $1 trillion to get the infrastructure that we need. It will take time. In the meantime, you can get it fabricated somewhere else at TSMC kind of places. So we actually develop a lot of SoCs that makes it very low power. So we developed a W band that is 90 gigahertz synthesizer. If you go to your lab and look at a signal generator, synthesizer or signal generator, how does it look? A big box, this kind of box that will weigh 5-6 kilograms. It will take about 15 to 20 watts of power. You cannot send an instrument out that one component is going to take 20 watts of power. Total instrument power budget for my instrument is 5 watts. 5 watts is a light bulb, right? A night bulb that you use. But that is the total power budget of your instrument. If the 25 watts goes for the synthesizer, then you are dead. So we came up with this VLSI based, that SoC that draws half a watt of power. These are the innovation that we are doing. Then we also similarly built a spectrometer, an entire spectrum analyzer that is on a single chip. And that's how we made that innovation. So we put everything together. You can see the instrument. This is my WhatsApp instrument. And I just, for a comparison in our lab, I am showing it how small this instrument is. This is on a CubeSat frame. And we actually launched it on a balloon to see how the instrument is performing. This is a gondola. And you can see that there is an alien hanging there. I call it Bob the alien, because the interesting story is from where we launched our balloon instrument in New Mexico, there's a town there called Roswell. If you don't know, you can do a Google search of Roswell. The people in Roswell believe that the first alien landed there. So when you have balloon instrument, eventually it will crash somewhere, it will come down somewhere on the ground. And that's why we wanted to make sure that when the people of Roswell finds our balloon, they will find another alien as well. So, and it flew very well, and we got very good data on this one. So we are now waiting to get a ride. So what will happen is we have this small instrument already. When you are going to Mars or somewhere else, on the way, this small instrument will be thrown out. And then we have our own capability of flying. We fly, have the propulsion, go to a comet and do this measurement and answer for once and all, did comets bring water to Earth? Think about it. If you are successful in answering this question, that's what is called the fundamental contribution. So we are actually very excited about this and waiting for a ride to go to a comet. Next couple of minutes, I'll spend a little bit about Mars helicopter. How many of you know about Mars helicopter? I know my little friend will be knowing here for sure. It's called Ingenuity. So we actually are flying a helicopter on Mars right now. So many of you will think, what is the big deal about flying a helicopter on Mars? There is helicopter on the sky all the time. There are a lot of challenges because, as I mentioned, Mars atmosphere is 1%, the density, 1% of our planet Earth. So when a helicopter flies on planet Earth, the rotor blades that they rotate, they rotate about 450 to 600 RPM, revolution per minute. But to get the lift that you need on Mars, they need to rotate about 2,600 to 3,000 RPM. Completely different. And if you have a small instrument, a small structure, and there's a blade that is rotating at this speed, it is a completely unstable situation. You cannot fly. So we went to NASA and said that we want to fly for the next mission, Perseverance rover mission, we want to fly helicopter because it is very, why you want to fly helicopter or any drone kind of instrument? Because the rover cannot go everywhere. Pragyan rover, how far it's traveling? Only, tens of meters at max. Our rover actually is traveling maybe a kilometer or so, but it cannot go everywhere. So if you have a drone or a helicopter that goes with that, it can take off, it can have instruments, it can have sensors, it will collect all the data and send it back to the rover, and then the rover will decide where to go to find those information. So that's why we wanted to fly. And NASA said, no, you cannot fly. The cost of the mission is about $2 billion. He said, if you fly a helicopter, something happens, we'll lose $2 billion. We said, we'll prove it to you that we can actually fly it. And we put our head together. So this is a very small instrument. Idea was that it will have only 2 to 3 minutes it will fly. It will go maximum about 30, 40 meters, that's all. And maximum distance it will travel maybe 600, not more than that. We want to show the technology works. And so it has 1.1 meter of blade diameter, and the blade speed, I already said, total mass about 1.4 kilograms, 1.5 kilograms, and power that was needed about 220 watts. So it has its own solar panels to do this, and it's completely autonomous. It does everything on its own. So we mounted the helicopter under the belly of the rover. You can see here, this is from Mars. These pictures came from Mars. So there was a protective cover. So first we dropped the protective cover. These photos are taken by the camera that was mounted on the rover. And then you can see slowly the helicopter was deployed, put it on the ground. And you can see here all 4 legs of the helicopter is now on the ground. And now for the first time, our small little helicopter is standing on its own on Martian surface. You can see the track marks of the rover that moved away after dropping the helicopter. And these pictures are taken by the nav cam, the camera that is mounted on the rover. The rover was standing about 40 meters away and taking this picture. We are very worried about small little helicopter Ingenuity because Martian atmosphere goes through a lot of temperature cycle. So we have done all this testing in the lab, but we didn't know whether it is going to work or not. And what you see here is April 19, 2021 was the first flight of the helicopter happened. This is a photograph taken by the helicopter itself, kind of selfie, but it is a picture on the shadow. It was mounted on the belly of the helicopter. And this is the real altimeter data that the actually helicopter sent us back. That helicopter lifted up about 3 meters, that is 10 feet. And the flight duration was about, I think, 40 seconds, total 40 seconds. And it went up there and then took about 96 degrees turn and then came back down. And we are all waiting. It happened at the late, about 3 a.m. in Pasadena time where I live. We are all very excited and waiting what will happen, like all of us So you can see this is a video that was taken by the rover. You can see this is the helicopter. This is the video of the first flight of the mission. You can see here, it went up about 10 feet and turned around and then hung out for about 40 seconds total. And then it will come back down. That's it. Just think about it. You are flying. This is the first time you flew something on another planet. How exciting that is. And as I said, that we actually had thought about 3 to 4 total flights. And so far, we have more than 50 flights of this helicopter, and we are trying to break it. And this instrument is not breaking. Why we are trying to break it? We are trying to find out how far it can go, how fast it can go till it breaks, how much maximum height it can go. Nothing is happening. This is a very rugged piece of instrument that we have built. And so NASA extended the life of this mission. So we are actually getting more and more data, learning much more about it. And based on that, we are actually developing the next generation of Mars helicopter that will do real science. That one was just a demonstration. So in future, we are actually going to send more helicopters on Mars that will do real science. One of them will have a radar. Again, SOC, VLSI SOC based a radar, single chip radar we are building for ground penetrating radar. So we are working on that in our lab. Actually, right now we have this helicopter more or less ready. The radar is ready. So it will be for the next Mars mission, we'll have this helicopter called Mars Science Helicopter will be flying. So with that, I will actually end and will be more than happy to take questions. Thank you. Thank you very much. Is there any questions from anyone? Yes, please. Yes, the question is debris, space debris. The question was that what will be the impact? Absolutely, that is one of the major concerns all the space agencies are having. So whenever I give a talk, people ask about space debris and ask me what NASA is doing about it. My question is what ISRO is doing about it, what ESA is doing about it. It is a problem for all of us. NASA does not have all the funding to clean up everyone's junk, our own junk as well, right? So it is a huge endeavor. First of all, yes, I'll come back to you. So first of all, we'll have to first detect those. Big chunks of debris are not a problem because we can see where they are, we can avoid them. Problem is the small chunks, small materials, because they're traveling at 70,000 kilometers, 80,000 kilometers an hour, and that can do a lot of damage, and we cannot really track them. Because tracking them, you need huge radar, you need LiDAR, you need optical imaging. That is the first part, we track. NASA is doing tracking for everyone. We track them and alert people that, there is danger. But how do you clean them up? There's a lot of ideas about cleaning them up, like send some nets like the way you catch fish, but it's not easy. Think about it, it's not really easy. So if any of you have any solutions, how we can clean up debris, come and talk to ISRO, talk to NASA, talk to ESA. We'll be very much interested in your ideas. Yes, you have a question. Can you introduce yourself first?
Sure.
See, we can fly a helicopter on Mars, but we cannot solve these problems, unfortunately. Yeah, it will work now.
Yeah. This is good. Okay. Thank you, sir, for a great talk. Thank you to the organizing committee, the chair, everyone for organizing this event and for allowing me to participate here as well. I'm Venkat Raman Patnaik. I am 10 years old. studying in grade 6 as under Akash International School, and I am really interested in space science, avionics, telemetry, and definitely human space flight, as well as propulsion systems. And this conference is a lot relevant to my interest. And as someone who stays in Sambalpur in Odisha, this was also a great opportunity for something happening at such a place like this in Bhubaneswar, because many of such conferences might happen in places like Delhi or Bangalore. So it is great to also have some places like this in the temple city of India for such an exciting conference. Anyways, coming to the question, this is about ingenuity. Of course, this is a very exciting mission at technology demonstrated. However, it is still exciting. So in the midnight time at Caltech at California, I suppose it was afternoon when I was also watching the live stream of NASA trying to fly Ingenuity, and I wanted to ask for the feasibility of such missions, because the next type of missions we are seeing here, we are making the Mars Science Helicopter, which is having more science, so more mass, and therefore more weight as well than Ingenuity. So that will mean that our blades, our systems will also be much different. The blades will be running much faster. So therefore, my question is, what is the type of feasibility of this type of mission, comparing it to, say, unpowered missions? Therefore, trying to keep our systems efficient and somewhat cheap as well. Thank you.
Thank you. Thank you. Thank you very much. Before I answer your question, I'll two comments I'll make. First of all, you should be on this side, not on the other side. And the second comment that I want to make, one of the reason I travel, traveling is not easy, but if I still do spend a lot of my time and a lot of sleepless nights, you are the reason that I do that. And so I'm so happy that you are here, and you are amazingly young man, and your articulation was so good. So answer your question, specific question, is a very legitimate question, because when you have, as I mentioned, the total mass of our Ingenuity helicopter is so low that we could fly, right? So in this case, for the Mars Science Helicopter, our blade will be much larger, not 1.1 meter anymore, because that is not going to give you the lift that you need. And also you need more power, because the instrument is going to need power. However, the instrument that we are developing is very low power, because we are able to do that because of the SoCs that we are using with the self-hold technologies that we are using, a single chip radar that we are building. Still, it will need more power, which means we need more solar panels. One of the questions you might ask, that why we are not using RTGs, that radioactive thermal generators. That's because they're nuclear power. As you know, we little bit of plutonium we use to generate those batteries, but there is possibility of life on Mars still. We don't know whether there is life or not. If there is any accident, any leakage, that will be disastrous for Mars. So we do not want to use RTGs. They're safe, but on these applications, we are not planning to use that, which means we need to have more solar panels. And in terms of the speed of the blades, we are not going to increase the speed of the blades, because they become extremely unstable, more than 6,000. So we'll have to see more efficient blade design that you actually mentioned. And if you can see, we are actually coming up with a new, it needs a village. when we, literally, when we are talking about this kind of instrument, we have mechanical engineers, we have thermal engineers, we have actually aerospace people who are very, the airplane people as well, who knows more about dynamics of this kind of situation. So we are working all together to come up with solutions that is more efficient. And we already have this because, we'll have to go through all these experiments. So for Ingenuity, we created in our lab an artificial Martian environment where the gravity was exactly like Mars, that you can do. And also we created semi-vacuum, like 1% of the atmosphere of Mars. And then we actually flew this helicopter to see, is it going to survive? So it needs a lot of investments, money. And we are doing it because we are very much excited about this, because it can do a lot of good sciences. And that's what we are doing right now. So stay tuned and see what happens. And I'm looking forward to see you one day in ISRO or NASA, Any other questions from anyone? Yes, please.
Good afternoon, sir. I have 3 set of questions, so I've just jotted them down. The first one that you told about, the first cosmic light that we discussed about. We know that light cannot be created, like the energy cannot be created, not be destroyed, but can be transformed from one form of energy to another. So at that point of time, what could be the possible conversion of energy that happened for the light to be created, the first light that we saw, the first light that the mankind knew about? So what could have been the possible conversion of energy, and what could have triggered this particular phenomenon?
Okay, yes, it's a very good question. The question was that, light, the energy that can be transferred from one form of the other. So the Big Bang, if you look at the theory of the Big Bang and the explosion that happened and the creation of the energy actually came all from the fusion, kind of the, hydrogen and helium, all these, that fundamental, that atoms were there, right? They got fused together because it created a huge hot plasma. So that energy, the first light that came out, it was not that it was not there. Because as the explosion happened in the Big Bang, it had created huge amount of energy, all kinds of energy, electromagnetic energies as well. But because of the hot plasma, it scattered in a way that it did not escape from that shell. So around about 380,000 years after the Big Bang, that some event got triggered that allowed, because one of the scattered light to actually escape from there. To answer your question, what was that event? I don't know. Scientists are trying to figure that out because we still do not have all these answers. That, it is an extremely complex dynamics to simulate, or, there is a lot of theories, of course, but theories are theories. Still, we'll have to do some simulations and do some measurements to figure it out. We do not know what triggered the release of that first light, but it happened because the scattering that was happening within it is kind of total internal reflection that goes on. So it escaped that, maybe at a particular angle that came out. We don't know yet. We are trying to recreate that, but the challenges are too much to still, come up with a real model that what exactly happened. Any other questions?
So I have 2 more. Can I?
2 more questions? Yes. I am available here.
Okay. Thank you, sir.
Okay, then that means no more questions, right? Okay. I understand. Okay, thank you. Thank you very much. And
Thank you, sir, for this amazing talk and inspiring all the young minds and researchers to study and research about space exploration and exploration of life outside our planet. Thank you, sir. Now I request Professor Jaideep Talukdar, sir, to felicitate Dr. Chattopadhyay. Please, please, sir. Thank you, sir. Now we are having a break of 10 minutes and all the presenters, please proceed to your respective venue for your presentations. And we will be having a group photo here.